Hello and welcome back to another video on derivatives. In this video we're going to do the derivatives of trig functions. So let's start with the two easy ones, sine and cosine. So we have the derivative of sine, which is going to be cosine, and then the derivative of cosine is sine, but actually with this negative sign, so you got to be very careful here. So sine will go to cosine, cosine to negative sine. So if the derivative of sine is cosine, then the derivative of negative sine is negative cosine. And then finally the derivative of negative cosine goes back to positive sine. So there's actually a cycle here. You start with sine, which will go to cosine, which goes to negative sine, which goes to negative cosine. And then it goes back to the beginning again. So one way that I like to remember it is to put them in this order, where you got sine, cosine, negative cosine. And then what you could do is you could just use these four letters right here. And then taking the derivative just means you would go down one level. And when you get down to the bottom, you would then go back up to the top again and then start the cycle over. Now we have the derivative of all the other trig functions. So for example, the derivative of tangent is going to be secant squared. So these are going to be the hard ones to memorize, but you will have to memorize them. The derivative of cotangent is negative cosecant squared. Now notice that there is a pattern here. Tangent goes to secant squared. Cotangent goes to cosecant squared. But there's also this minus sign here. So just remember that there is actually a pattern. Tangent to secant, cotangent to cosecant. Now the derivative of secant will be secant tangent. So again, maybe you see this now, that secants and tangents match up. So then the derivative of cosecant would be negative cosecant cotangent. So again, you'll have to memorize these four. So let's go ahead and start with an example. Why would taking the derivative of trig functions be difficult? It's mainly when you have them inside product rules, quotient rules, and chain rules. So here's an example of one where it is in a product rule. Notice you got 3x squared times, and then you got a sine x. So let's go ahead and do this problem. Okay, remember that what you're going to do is you're going to call one function f, which I'm going to call 3x squared, and then you need to find its derivative, which is pretty simple. It's just going to be 6x. And then we got to find the derivative of sine. Or I'm sorry, let's first identify that as g of x, which is sine x, and then its derivative, which is going to be g prime, is cosine. Now what's the formula for the product rule? Remember, it's going to be f g prime plus f prime g. Again, you might remember this as flipping these two, or you can have you could do f prime g plus f g prime. Okay, these are the same thing. So let's go ahead and write it out now. We have the derivative. It's going to be f g prime. So we have f times and then g prime. So g prime is cosine x plus, and then you got f prime. F prime is going to be 6x times, and then g. And g is going to be sine x. Now we could factor this a little bit. Notice that they both have a 3x that I can pull out, which means that I have x cosine x plus 2 sine x. So you can leave your answer like this. Alright, so our first example is done. Let's go ahead and move on. Now in this example, we have a quotient rule, we have a numerator, and we have a denominator. So let's go ahead and find its derivative. Okay, we're going to call the numerator here, and it's the whole numerator. I'm going to call that f of x, and then I'm going to call the denominator g of x. And the formula for the derivative of this, which would be the quotient rule, remember it's going to be g f prime minus f g prime all over g squared. So we need to identify f and g. So let's go ahead and do that now. We already did f, which we said was tangent x plus secant x. And so its derivative The derivative of tangent is going to be secant squared. Again, you're going to have to memorize that. And the derivative of secant is secant tangent. Alright, let's go ahead and do g. We said g of x is, where's that at? There you go, 1 minus cosine. And so g prime, well, the derivative of 1 is 0, and the derivative of negative cosine. Again, you can go off to the side and say s, c, negative s, negative c. So the derivative of negative cosine, which is this piece, goes up back to sine. So g prime is actually going to be a positive sine x. Alright, so we're good now. We can start the derivative. We have gf prime, so g is going to be 1 minus cosine x times, and then f prime, alright, minus, so we got minus, and then, what is it? F g prime. So f is then going to be the tangent. We're running out, so I'm going to have to move this over. Tangent plus secant times, and then g prime, which we said was sine. And that's going to be all over g squared. Now g is 1 minus cosine x squared. Now this one, notice that you have an exponent here, and that exponent is kind of between the sine and the x. Alright, so you got to be very careful because this is a shortcut notation. It doesn't actually, you don't actually work with it like this. So when you're trying to find the derivative, what you have to do is rewrite the problem, and instead of sine to the 4th of x, you would rewrite this as sine x all raised to the 4th power. Okay, so that's what this actually means. So notice that this is going to be a chain rule. What you're going to do is you're going to bring down the 4, right? You bring down the 4, and then you leave the inside piece alone. So you're going to leave sine alone. Subtract 1 off the exponent, so we get 3. Then you multiply by the derivative of the inside. Now the derivative of sine is cosine. And that's actually it. This is the derivative. So here's some examples that I want you to try. Notice that I do have that sine to the 4th show up, but it is inside a product rule. Be very careful. This is the tangent of, and then you have stuff inside tangent, and then secant of 1 over x squared. Make sure you rewrite the 1 over x squared in the correct form. Right? Remember, x to the negative 2. Otherwise, you can't do the power rule. So the solutions to these problems and more information about NIU, please visit the link right here. Good luck.